Back to Further Solutions Academy, Further Solutions Academy. Encourage us more, help us to share our video to your friends and also subscribe to our channel. Help us to share to your friends, and if you have not subscribed before, please kindly help us to subscribe on it. We have over 160 videos on this platform. It means you can come to this platform and learn any topic of your choice. Presently we are working on complex analysis, now which I will be working on residue. I will just summarize residue. I will summarize residue, which is summary of residue. I don't need to be explaining all what is in your textbook or everything. How do I calculate residue? How will you get it when you have it in any exam? And how will you get your residue? That is what I want to go upon. Now we have been on residue. It wasn't series. We have done Lawrence series. We have done McLaurin. We have done Taylor series, and we have done some proof. We have done how to show 90 parts and how to show principal parts. Now this video I will just summarize how to build. How to solve simple residue. Without any problem. Now, in our summary, we have explained in terms of a residue. Residue is just like way of integrating, or we are differentiating a contour part of a particular plane. Now, I don't need much. Go and read more on that. You understand that. Now, we have three methods on this residue that you can use. Three methods, and the method depends on what you are working towards. Example: the first method, method one. Method one. Now, if you are having E of Z all over Z, now this one will be having 1 plus, which is equals to, normally I'll be having this, and I'll be having this 1 all over Z bracket of Z plus Z square all over 2 factorial plus 3z all over 3 factorial plus, and so on and so forth. Now, since I have it this way, now provided at that z of 1 equals to 1 all over z plus 3. Now, which the coefficient of z minus this is residue. Now the coefficient of that is residue. Now with what I'm doing here, it means from here, it means I'll be having 1 all over z bracket of 1 plus z squared all over 2 factorial plus z3 all over 3 factorial plus, and so on and so forth. Now, it means I will be having 1 all over z plus 1 plus z all over 2 factorial plus z squared all over 3 factorial plus, and so on and so forth. Now, what is there is that the coefficient of what is there. It means any number that is there, which is coefficient of the of this which is 1 is the residue. That is 1 is our residue. It means what is attached here is what is 1. Coefficient of this number of this 1 all over c, which is z, what I'm just saying, which is a z inverse, it means that is our residue. That is what we are talking about. It means when we are relating with exponential form, you can go on the first method. Now, method two. Method 2 is all about we are trying to differentiating and getting some things. Now, method 2. Now, if I'm talking about method 2, I'll be having residue of function of p, which is equals to limit of z tends to p, integral of this b, that will be condition 1. Condition 1. Now, is a condition 1 because of what? This my function, it has no power. Now, when my f of x has a power, for instance, we are talking about, that is number 1. Condition 2, residue of this p which equals to d of dz with a limit of z to p, open a big bracket of z minus p squared f of z with a which is a condition 2. Now condition 2. Now condition 3, residue of fp of this, when I have 1 all over k minus 1, d of k minus 1 divided by d z k minus 1, it means I'll be having, open a big limit, I'll be having my, I'll be having my limit z to p, which is into bracket of z, into bracket of to bracket of z minus p of k, f of z, or bracket of that, which is my k must not be equals to 1. My k must not be equals to 1. Once my k is equals to 1, there will be a big problem. That is condition 3. Condition 3. Now, that is conditions on condition 3. That is method 2. But in method 2, we can have first condition when there is no power. The second condition is if there is power of 2. And the third condition is if the power is more than 2. 3, 4, 5, and so on and so forth. It means this one will differentiate in the number of times. If it is power of 3, we differentiate it in 2 times. If it is not power of 4, it means we differentiate it 3 times. You will see, maybe when I'm doing the example, you will see how it looks like. Now, that is method 3. Method 2, which is having condition 3 conditions. Now, the next one I'll be playing with, I have method 3. Method 3 is always very simple, and it means I'll be having residue of p, which is equals to a of x divided by b prime of this. Now, for trig function, for trigonometry function. Now, it means it's always useful for what? Trigonometry function without any stress. Now, I've given example on number 1 on the first method, which is by using e of z all over what? All over z. We have done something like this, which is my residue is 1. Residue is equals to residue is 1. We have done this now, and I will try to, maybe I can give this method on the second one, on the third one, if time permits me. Okay, let me try to give example on the first method, which is third method, which is, I will try to give an example on this method option. Now, it means number 1, when you have a problem, you must know where the question is coming from. Where the question is coming from, I'm going to detect the question, you will know the kind of method to use. If it is method 1 or 2 or 3, anyone that is suitable for the problem. Now, for instance, I have determine all singularity singularity of z minus 1 divided by sine z, and compute the residue of the singularity. Now, if I have a problem this way, if I have a question this way, I want to solve it. Just like solution. The first thing I will know is that my f of z, because it must be a z, because we are talking about what complex analysis, it must be in form of z because it's complex analysis. Why are we talking about z? I think I've told that, I've explained that in our previous video. You can check on that, which is I have z minus 1 all over sine z. I have z minus 1 all over sine z. Now, this is method 3 without no problem. This is method 3. Now, my method 3 is allowed here. Why? Because of it's a trig function, which is my function is on trig. Okay, my function is on trig. Now, it means how do I go on this problem? It means I must know that my a. Now, because it's a trig function, it means I must to learn to use the method 3. What is my method 3 saying? What it is saying is what? The residue of f of p equals to limit of z tends to p and a of x all over b prime of x. Now, it means my a of x equals to z minus 1. My b of x, it will be what? Sine z. Now, my b prime of x, it will be cos z. It means, cos z, not x. Sorry, I'm very used to x. Now, cos z. It means I can now say that what? The singularity is at z equals to 0, comma, z equals to pi, and z equals to what is not this thing? Minus pi. That should be my singularity. C equals to that, z equals to. Now, these are my singularity. Now, let's try to test for, because of what? This is a trig function. And when we're talking about trig function, we always, you know about their curve. We have done that earlier. It exists at 0 and minus pi and also pi. Minus pi is always 180 in terms of degree, and 0 is on its own. It means minus 180. And what I'm trying to say here is that I'm talking about something like this. This should be your minus pi. This should be your pi, and this will be your 0. The function is always like, if it's a sine function, it's always like this. Sorry, please take note of that. It means the curve will curve at a point here, and also at a point here. That's what I'm trying to talk about here. Now, it means at a point here and at a point here. Now, it means whenever you are having a trig function, you must consider your singularity at 0, at minus pi, and also pi. Now, you will now see that what? At residue of a function of, let me start from 0, singularity of 0. It means I'll be having limit of equals to limit of z times to 0, and what is my a? I have z minus 1 all over cos pi. Cos 0. Okay, cos z first. Now, it means, is there anything that I can now limit this function, which I'll be having 0 minus 1 divided by what? Cos 0. Now, my cos 0 is always equals to minus 1 all over 1. Cos 0 is 1. We have done that earlier. Cos 0 is 1. Now, Okay, it means it to be here it will be -1. Now the next one is my residue of f of pi. It means I'll be having limit of z tends to pi and pi, okay, no, z, which is -1 divided by cos z. Okay, divided by cos z. Now it means I can move on by having pi -1 divided by cos z, which I have pi -1 divided by cos pi. Cos pi is always minus, cos 180 is -1. Now we're having -1. It means my answer will be minus pi plus 1. Minus pi, or we present it as or the same thing as 1 minus pi. 1 minus pi. Now another one is that is my p of f of minus pi. It means I'll be having limit of z tends to this, we'll be having z minus 1 divided by cos z, and which is I'll be having minus pi minus 1 divided by cos minus pi, which I'll be having, this will be minus 1, which is going to be -1 minus pi plus pi 1 divided by cos, that will be -1. It means I'll be having cos minus plus 1. Now that is my residue. Now since I have them like that, that is all what I need. That is all what I need on that aspect. Now you can see how it's being done now. That is very simple to attach to work on residue. I think okay, let me just try to put one more example on this residue, because it won't not much, it won't cost us much to do it once and for all. Let me look for a function of that will be very simple to hold on to. Now, okay, let me look for a function of this case. I'm having let me have a z plus 2 divided by z minus 2 z minus 1. Now, I want to work on this particular problem. Solution to this one. I've changed the question to this. Now, this time around, I'm working on method 2. I'm working on method 2. The first thing I want you to know is that this time around, we are not talking about exponential function. Rather, we are talking about a trig function. It's a normal function, which is we are having f of z. Now, there's no picture of it. It means I can easily say that my residue will be solution. Now it means singularity comes at z equals to 2 and z equals to 1. Now that is my singularity. It means factor of this, factor of this. Now this is factor of this. I mean the root of this factor will give me singularity. Since I have then that, I can answer that what, and we all know that this is method 2. We're talking about method 2. This time around, I've used method 1, I've used method 3, and now method 2. Now, it means my method 2 will give me something like residue of p, which is limit of z to p, bracket of z minus p f of z. That is my residue. Now, it means because these particular functions, these factors, none of them has power. None of them, they are all in power. Both of them are in power 1. Now, it means at z equals to 2. At z equals to 2, it means my residue of f of 2 will be equals to limit of z to 2 bracket of z minus 2, and my f of z. My f of z is always equals to what is it? Z minus 1, I mean z plus 1, z minus 2, and z minus 1. Now, it means this will cancel this will cancel that. Since I have it that way, it means I'll be having my limit of z to 2 will be z minus plus 1 divided by z minus 1. Now, at this point, I can now continue my function by having what's the name of this thing? I have now it means I can now limit, which is 2, I'm having, which is 3. We have done limits of a function, and also we have 2 minus that will be 1. My answer will be 2. My answer will be 3 rather. My answer will be 3 because 2 minus 1 is that. Now it means that residue is 2, and it means singularity is at 2. The residue is what? Is 3. And also we can move on to the next one, which is at z equals to 1. It means I'll be talking about residue of function of 1, which is equals to limit of z to 1 of z minus 1 and z plus 1 divided by z minus 2, z minus 1, which this will cancel this. Now it means I will have the same thing, which it will be what is it? I'll be having limit of z to 1, which is z plus 1 divided by z plus minus 2. Now, which is I can now perform my limits. 1, that will be 2 divided by minus 1, which is my answer will be minus 2. Minus 2. That is all what you need to know on that part. Now, if that the thing continue like that, there are some things that you need to expatiate, which is you need to add more things to it. Okay, with what is on ground, I think okay, now I think there is a mistake at the point. At this point, it's supposed to be d of the z. Sorry, d of the z. I think there is a mistake. And also here we're supposed to differentiate d of the z. Now it means before we arrive there, we must differentiate it because we're talking about residue at one point. I did not follow the information very well. Okay, I think sorry for that mistake, because I've told you the first method, which is I will differentiate this, which I'll be having limit of z to 2, which d of the z into bracket of z plus 1 divided by z minus 1. Now, I think I will differentiate it with our function of function, which I'll be having limit of z to 2 into bracket of, if I differentiate this, I'll be having z minus 2 minus z plus 1 divided by z minus 1 squared, which I'll be having what again? I'll be having I'll be having z, which is I'll be having minus 3 limit of z to 2 minus 3 divided by z minus 1 squared. Now I can now limit it. Sorry for that mistake. It means when I limit it, I can now say that I'll be having minus 3 all over 2. This is 2 minus 1 squared. 2 minus 1 is always minus 3 all over. That will be 1, which is 1 squared is 1, and my answer will be minus 3. Sorry, my answer is minus 3. And also the second one at z equals to 1. It means my residue of f of 1, it will be limit of z to 1, d of dz, bracket of, we have the limit of this function, which is I'll be having the function in this form, z minus 1 and z plus 1 divided by z minus 2, z minus 1. Now, this will cancel this. It means I'll be having equals to limit of z to 1 and all over dz and z plus 1 divided by z plus minus 2. Now, differentiate also. Sorry for that mistake that I did not follow the step, which I'll be having. What am I going to have then? I'll be having now z minus 2 minus z plus 1 divided by z minus 2 all squared. We are talking about a limit at this point to 1. This also will be, it will be equals to limit of z to 1, which is minus 1. Okay, now we'll be having minus, this will cancel, minus, that will be minus 3 also, divided by z minus 2 all squared. Now, it means I'll be working on 1 squared, which is, it will be also be minus 3. Okay, 1 squared, which also it will be, I'll be having this, I'm coming. Now, I need to rub this part. It means I'll be having, yes, this will cancel, minus this, that will be minus 10. Yes. Okay, minus 3, which I'll be having, okay, minus 3, which is minus 3 all over minus 1 squared, which it will be equals to minus 3. That is my answer. That is the residue of both. It means the residue of that and that. Now, which is, because of these ones are of degree 1, that is why we need to differentiate. If it is degree 2, we have to do that also, and so on and so forth. That is all about residue. With this, you can get what residue means, and you can continue from there. I think from what we're having here, complex analysis is now settled. But before we call it a day, let me try to introduce some part of residue. That's when we are talking about contour integral. You can use it to solve some problem. Really helpful. I will just break it down. I won't solve because there's no time here in my studio. There's no much time here. Now,